So I'm going to post the key to this, but I figured I'd go ahead and give you videos too in case there was anything you didn't understand. I know that there's one question in particular a little later in the test that's pretty challenging. So the first question, I see first thing 10%. This is already telling me that we're probably dealing with a test for proportions, right? And we even have sort of what our variable of interest is. This is whether or not those graduate students live on campus. So our categorical variable with a yes, no. Dun, dun, dun. They think it may be more than 10%. So now I've got something about them thinking, which means we've got a claimed value and we've got a direction. So I already feel confident at this point to come in and write down these null and alternatives. So either the proportion of graduate students who live on campus is equal to 10% or it's more than 10%. All right, the housing office does a survey of random students, and now we've got our actual evidence. 62 of the 481 respondents. So we've got our X of 62. We've got an N of 481, and I know I can use those to create a p-hat. And if they've collected evidence, this p-hat should be larger than 10%, which it is. So let's just see what this is. 62 divided by 481. And if you're somebody with a big calculator, you could already begin. This is 189. Big calculator, you could already be doing one prop Z test. You have enough information. I haven't even finished reading the problem. Perform a hypothesis test, which is what we knew. It was the warm and fuzzy, to determine if you would recommend that the housing office increase the number of houses available. Okay, great. Test statistic. This is where I'm going to go to my formula sheet. Proportion hypothesis test is going to give me this formula. Which would give me 0.1289. How different is that from 0.1? Need a standard deviation. It looks like we should get a z-score of 2.11, which is completely fine to round 2 decimal places since that's the best we can do in the z table. Where they're going to look that up, my shortcut, I'm going to look up negative 2.11 in the z table. Oops. If I wanted to, I could even draw pictures at each section of this to see what I'm doing. The first picture would be that we're saying, what if p is 0.1 and we got out 0.1289? How unusual is that? The second picture is, okay, I got a z-score of 2.11. How unusual is that? So just sort of a reminder, and the reason I'm only shading half of the right tail is because we have a greater than for both of those. So if I look this up in my z-table, I have to go grab a z-table because I did not bring any. I don't have one open on my computer. It looks like negative 2.11 would give me 0.0174. 0.0174. And then we're going to make our decision, 0.0174. We're going to compare that to a given significance level of 0.05. It looks like this is smaller than, so we get to reject the null, which means my conclusion is going to start with at a 5% significance level. There is enough evidence so remember, all of this is coming straight from part D, so the significance level, and there is enough evidence. And then to conclude, and we can talk about either the alternative in words, so we'd say something like the true proportion of graduate students looking for housing is more than. Or we could say that they should increase their housing options. So the last piece here was the most challenging, and you can see the double star, it was extra credit. In addition to the 481 graduate students who responded to the survey, there were additional 19 who did not respond. If those 19 responded, would the recommendation have changed? So right now, my recommendation is to increase housing, right? We decided that the 0.1289 was larger, statistically significant, larger than 0.1, right? And that was based on, what was it, 62 people? Yeah, 62. That was our current thing. So our evidence was 62 out of the 481. So the question is, would we change our decision? So the only way that these people would change our decision is if they gave us evidence in the other direction or less evidence than we had, right? So these 19 people, what would have needed to be true about them is these 19 would have people had to say no, right? And in that case, we would have converted this value to 62 out of 500 instead, right? Because the 19 people, they wouldn't have gotten added to the top because they said no, but they would have been added to our sample size. So this will weaken our evidence. So now instead of 0.1289, this is math I should be able to do in my head, but I cannot. So it is like 4 in the morning. 62 divided by 500. Now we're looking at 0.12. And the question is this statistically significant still? So we have to rerun the entire test, which is easier if you have a big calculator, but I'm just going to bring back some of the work I did before because it's not that bad. I'm going to go back up here and change that to a 4. So it would change our z to 1.75. If I look up negative 1.75, I still end up with 0.0401. I'd say still, but I end up with 0.04, which is still less than alpha of 0.05. So no, the decision doesn't change. So annoyingly, you had to do like a whole new hypothesis test to answer this question.